Welcome to the lesson 15 preview exercises for Math 107. We're given a graph of f of x, and we want to use this graph to graph g of x, which is a transformation of f of x. It's 3 times f of 2x. We're going to graph it on the same set of axes. We're going to start by labeling the 5 key points A through E, and then change their coordinates according to the transformations. So let's see, I'm going to write 3 f of 2x. Remember that g of x is 3 f of 2x. Yep, okay. So now I can see my formula and my graph and my table all on the same screen. Okay, so A is -6, 5. B is -2, 1. C is 0, 7. D is 2, 3. And E is 4, 5. Okay, so to transform the x coordinate, I am looking at the transformation that's being done to x. Transformations that are in the parentheses inside the function are sort of the opposite of what you might expect. So that looks like 2 times x would be doubling x, but actually what I'm going to do is take half of x. So for each of my x coordinates, I'm going to half them. Halve the x's. All right, so this becomes, my x coordinates are -3, -1, half of 0 is still 0, 1, and 2. All right, now to transform my y coordinates, that 3 is what's transforming the y's. That says 3 times f of x. It's an outside transformation, which means it's changing y. And outside transformations are exactly what you expect. So I am going to triple all my y coordinates. So I'm going to do y times 3. So each of my y coordinates are going to get tripled. So they become 15, 3, 21, 9, and 15. So these are my coordinates, -3, 15, etc. So I'm going to graph these points on my original graph here. Okay, so -3, 15 is about right here. -1, 3, 0, 21, 0, 21, 1, 9, and 2, 15. 1, 9, 2, 15, and connect those. There we go. So that is a W that has been vertically stretched by a factor of 3 and horizontally shrunk by a factor of 1/2. What is the length of the domain of G and how does it compare to the domain of F? Okay, so F is my original function and its domain goes from -6 to 4. Domain of F, -6 to 4, which is a length of 10. And then the domain of G, so here G goes from -3 to 2, which is a length of 5. So my domain halved, which corresponds to the fact that we are doing a horizontal shrink by a factor of 1/2. All right, let's look at the length of the domain of the ranges of f and g. So the range of f's the original function. The smallest y value is 1 and the biggest is 7. So the range of F is 1 to 7. The range of G, smallest y looks like 3, and the biggest y is 21, 3 to 21. So my length was 6, and my new length of G is 18, and that corresponds to the fact that we did a vertical stretch by a factor of 3. My range is 3 times as long as it used to be.